This is number 35 on page 310, and you may wonder, why is this problem in the quadratics unit where I'm going to be using completing the square to solve it? And so we must end up with a quadratic equation eventually when we simplify this, because this looks like a rational equation with these ratios in here. Anyway, we do know that we can clear the fractions multiplying everything on both by rewriting every term over the LCD in this problem, and then clearing the fractions. So let's figure that the lowest common denominator is the y plus 2 times the y plus 6. Okay, so this term here is going to be multiplied by 1 in the form of y plus 6 over y plus 6. And this term is going to be multiplied by 1 in the form of y plus 2 over y plus 2. And the 1 here has to be multiplied by the entire LCD over itself. Okay, so this is a form of 1, this is a form of 1, and this is a form of 1. So now it's all over y plus 6 times y plus 2, so we can clear the fractions by multiplying both sides by, put it down here, by the LCD, and those denominators go away. So I have y plus 6 times 1 plus y plus 2 times 1 equals y plus 2 times y plus 6. And this is where we can see, oh, I can see why it's going to be a quadratic equation. So on the left here, I'll have 2y plus 8 equals, when I multiply this out, I'll get a y squared plus 6y plus 2y. It's an 8y plus 2 times 6, or 12. So I'm going to move this to the left after, but I'm going to subtract 2y from both sides. So I will have a y squared on the left, minus 2y minus 2y. I'll have a plus 6y, and minus 8 will give me a plus 4. And instead of putting the 0 on the left, I'll just put it on the right, so I'm used to that. And now I'm going to complete the square. So now we see why this is in the completing the square section, because it can't be factored. There's no factors of 4 that add to be 6. So I guess I'll move that 4 to the other side and leave a blank to complete the square. So minus 4 plus blank on each side. So start the process. I want this to be a y plus 3, because 3 is half of 6, quantity squared. If I FOIL out y plus 3 times y plus 3, then this term in the trinomial will be a 3 squared, or 9. I have to add that on both sides. So now I have, what my goal is a squared expression equals a number, and the number is negative 4 plus 9, or 5. So now taking the square root of both sides, y plus 3 is equal to the positive and negative square root of 5. So y is equal to negative 3 plus or minus the square root of 5. And that represents two solutions, negative 3 plus root 5 and negative 3 minus root 5. Those are the two roots, and they happen to be conjugates. And that's it for number 35.